Okay, everyone. Good afternoon. Today, I will be talking about our latest work on evaluating web agents on website security and privacy tasks. Now, this work was done by Guruprasad, me, Basieem, and advisor Kassem. Unfortunately, Guruprasad could not be here because of travel restrictions. So I will be presenting this talk. So, what are web agents? Now, web agents are basically systems that can help you in automating various repetitive tasks. For example, let's say you want to add some groceries to your cart. You could ask a web agent to do it for you, and it will gladly do it. Now, this has existed for a long time where we have various scripts that can do these things. But now, with the advent of LLMs and all, there are a lot of LLM powered web agents that can do things like online shopping, trip planning, food delivery, and various other things. Recently, there was a trend to ask Claude to review your resume and then automatically apply for jobs. So that's also something you can do. Um, so now that we have this LLM powered agent, let's take a look of how they are actually working. So at any point t of it solving the task that you had given it, it needs a context to figure out the next task. What it takes in as context includes your initial instruction, what the current screenshot of the web browser is, what all past action it has taken, as well as the past screenshots. All of this contributes as the context, which then goes to the LLM, VLM, whichever. And based on this, it decides what kind of action to do. That action goes to a automation tool, and the tool executes this action. Once this action is executed, it captures the new observation or new screenshot, and basically all the steps that it did, like the actions and the new observation and the current observation, basically go back to past observation, past action, and then the new observation becomes your current observation, and so on. And this loop keeps on going till you finish the task. Now, there are a lot of benchmarks that exist that look into how well agents can perform this for general purpose or information retrieval tasks, like can you book a flight for me or things like that. And there are some benchmarks that exist that look into uh, are agents vulnerable to prompt injections, or do they get confused when they are navigating a task. But something that we noticed that does not exist is that there are no benchmark that look into if agents can securely and correctly perform security and privacy tasks on a website. This includes tasks like updating your cookies based on your preference, or setting your profile private, opting out of, let's say, using your data for some AI training. So to evaluate that, we come up with a framework called a WebSP-Eval that basically looks into evaluating a web agent's performance on similar website security and privacy tasks. Now, what it includes is, first we have to do some curation. So we take some sample websites, we look at what all security settings are there, what is the default settings that are present, come up with an instruction, take this together, and this creates a task instance. And I will go in detail of what exactly is happening here in the next slide. And then there is the agent instantiation, which involves creating a browser session where you have logged in so that the agent can perform these kind of tasks, because they're often behind the login screen. Setting up the initial state so that every agent gets the same state so that we can evaluate it on. And then we let the agent perform the task based on our instruction. And then comes the evaluation, where we do an automated verification by taking the agent's trajectory, the ground truth that is manually curated, as well as in the initial task instruction. And we give that to a judge, LLM judge, to come up with a verification to say that if the task was successfully completed or not. So let's take a look at how task curation happens. So for task curation, we go to like the top websites on Trango, as well as other benchmarks and what they have used, those websites. which leads us to around 28 websites from 9 different categories. And the categories are written in our paper, so do refer to that if you're interested. And next, we have to come up with these security tasks. So what we did is we went to various government cybersecurity websites from FTC and other European countries, and we came up with these tasks of what um constitutes a privacy security task. Then we would try to find these tasks on the website as well as their initial default state, and based on that, we would design our instruction to ask the LLM to either interact with it and change it in some way. And doing this, we came up with around total 200 different task instances. Let's take an example of a task instance. Let's say the task is to disable the toggle for marketing, customer research, and goal newsletters on a website. So that means there can be one state where every toggle is switched off, and there can be one state where every toggle is switched on. And we want to evaluate the agent's performance for both of these states. So with our state reset, what we'll talk about next, we are able to do it. So for agent instantiation, we first have to log in, and to log in, we do like Google account login. So we can just sign in with Google, which primarily works for most of our um, websites. If that doesn't work, we go back to the standard email authentication, and this is like just a Selenium script that does this. Next, we have to set these initial states. Now, to do this, what we did is we would record a human trying to solve this step, and once that trajectory has been recorded, we would replay this and set our states as we want. We can set something as switched on, set something as switched off, and so on. And then we would let the agent execute the task to completion. And we would capture the screenshots and the responses that the model would come up with. Now, these agent trajectory, responses, ground truth, and task instance goes to a judge LLM, which comes up with a answer if the task was completed or not. Now, this evaluation was done on 8 different LLM models, and the judge consisted of like a majority voting ensemble of 3 models. And we did validate the judge on actual human annotated data, and it achieves a score of 95 to 96% of F1. So the research questions we wanted to answer is how well these agents can perform these tasks if they have explicit navigational instructions, which means like we actually tell them go this direction and then do this task, or just randomly say go to this website and do this task. The next question we want to ask is how does this performance vary across different websites and task categories? And then how does UI element and the initial states affect models? And lastly, how robust are these agents' performances? In the interest of time, I'll just be talking about RQ1 and RQ3. So on the navigation information, we saw that by default, with navigation led to better results or better success rate compared to without navigation. Interestingly, we saw that closed source models perform much better compared to open source models and smaller models. When we look at the UI element, we find that easy elements like link and buttons can easily be like the failure rates are very low, so model can interact with that easily. But for checkboxes and toggles, there's almost a 50% failure rate. Similarly, for like if the initial state is on or off, it seems like agents can perform much better when the initial state is on other than off. And then lastly, we did like a manual analysis of why all these failures happen. And we found that mostly these failures happen because of hallucinated success and incorrect navigation. And yeah. So here's an example of an interesting failure. We asked Gemini 2.5 Flash to sign out of our Pinterest account, and it decided that deactivating the account would be a good way to sign out. So it ends up going through the entire trajectory of deactivating our account. uh, which led to a lot of issues because we didn't realize that our account got deactivated. Uh, so the takeaways is that there is no benchmark, so we come up with a new benchmark to evaluate web agents on live websites. And then we also are the first benchmark and framework to use this on user accounts tied to live websites. And we find that agents struggle to navigate and solve everything autonomously, and that there are various design elements like toggles and checkboxes that lead to a lot of errors. This was the team behind this experiment, and here are some QR codes. I have posted there, so if you have any questions, want to see some more interesting examples, please feel free. Thank you.